Okay, so people are coming on board now, which is good. It's that time of year, it's getting a little bit hard, isn't it, to get to sessions, which is quite tricky. I'll try and keep my chat box open so I can see things coming in by chat for people who don't have audio or visual. And okay, so right, everyone's got sound again. Fantastic. There was obviously some gremlin going on. You may have noticed if you've been on the Moodle, it's shutting down in about 10 hours and 55 minutes and 42 seconds. Obviously for maintenance, and maybe that's got something to do with the issues as they're coming up in terms of tonight's session. But let's hit the record button, and I think I've done that already. Yeah, we are off and running. Let's get going. So this week we're going to talk about Earth, space, and biological sciences. It's my favourite strand, and it's one of the one of the strands too that kids can really get into. So let's not waste too much time getting excited about it, because let's face it, we've got the ebook there. So, and in the ebook, what I've tried to do this week is take you through a lot of different examples, and try to connect you to some of the NASA sites. Some of the existing resources that are being kicked around in schools in science by doing units, and hopefully with a view to giving you access to those resources going forward, so that when you get into your teaching career, you've already got a little bit of a map of where things are. And I saw the resource Loretta posted today too. Thank you very much for that. That was a really great little resource. So if you haven't been on the forum and had a look, please do. But what this week is about, we're looking at Earth and space science, and I don't think Loxley does it that well. I'm not going to critique. It's a massive area, and it's a massive field, and unfortunately, Loxley has 2 chapters dedicated to it. But again, I remind you, this subject is not about mastering science understandings. It's actually about learning your way around the science curricula and being able to develop the capabilities to become a science teacher when you need to be one. Okay, so it's not about mastery. Mastery doesn't work. Shelf life of knowledge is halving every 12 months now. Knowledge is rewriting itself. So there's no way we can learn and remember it all. What we need to do is skill ourselves in knowing where to find it. So the Moodle this week took us on a happy little journey. We had the Galaxy song from Monty Python, we had Chugs and God, and we had Homer Simpson. So we're bringing a cast of people to this little catalogue here. And the whole aim of that is saying, well, science is full of misconceptions. Everybody's got a finger in it. And kids, no wonder, it's difficult for them. It's challenging for them in this world, as it is with most things. Anyone who watches South Park, I'm a huge fan of South Park. And one of the reasons being, of course, it's all about 4 kids. And they're not really kids, we know they're adults, but they live in a world of enemy and alienation. That is, there are no real values in the world, and alienation, people are alienated from each other, from production, from connection, and it's just a real parody on real society, a tragic parody, but a funny one at times too. So what is this week? It's about getting rid of the misconceptions and setting in place some really clear understandings. Now, if we get that the Earth is one of 9 planets, debate, the Sun is a star, stars cluster to form galaxies, a couple of principles we can actually lay down here in our own mind. If we're confident and can justify a couple of assertions like these, then chances are we can teach Earth and space science very successfully. The Milky Way is one of only 100 billion galaxies. You may have read the news. Did anyone hear the news this morning about the biggest black hole ever discovered? Fascinating piece of news coming today. And the article that's reporting the discovery 2 days ago is suggesting that possibly this was the beginning of the Big Bang. This black hole is so big. And it's so far away from us at the moment, it's no threat. But it's basically consuming most of the universe or multiple universes as we observe it. So it's a massive black hole. Again, if you haven't read that yet, have a good look at the article, because it really makes good classroom discussion. Most galaxies look like stars to us. The solar system is on the edge of a spiral arm in the Milky Way. It rotates around the centre of the galaxy once every 250 million years. And relative to the centre of the Milky Way, our solar system rotates at over 200 kilometres per hour. So anytime you want to be the fastest person in the world, I suggest you drive up to the Atherton Tablelands and you travel along at 100 kilometres an hour, because in real space-time, you'll be doing 1,100 kilometres an hour. So these are little things that we can excite kids with, little riddles, the little mysteries of the universe that we can really use as hooks to get them into it. I also put up Phil Hellenes this week to get some, to get some stimulation going. It's an engagement hook. Now, Phil goes off on a tour de force. He takes it away and turns it into an argument against organised religion, when in fact, he's a universalist. He believes that we, in universal science and in the origins of the species and all those kinds of things. And he's very much a scientist in his thinking. And his presentation, is therefore merges into a critique on Christianity. But what it really does, what it really attempts to achieve is the application of scientific knowledge, wonder and awe. And so it is an incredible engagement hook, probably not one I would use for young children, but certainly one that you can stimulate some upper primary school kids with, and perhaps even make their own video along the same lines. But you can take children along on this journey. When was the earth conceived? When did it come into being? And you can get a wonderful blend of philosophy, science understandings, human endeavour, science inquiry. All of these things, metaphysics, can roll into one. And we look at some of the First Nations myths. We go back to ancient Egypt, and they talk there, that their mythology or their cosmology and mythology blended together is about a watery abyss created by the god Ra. And Ra created everything else. First he blew air, and then he spat the first moisture. And humans actually formed from Ra's tears. And we can see, a great deal of spirituality in that kind of interpretation. So, we can see a lot of similarities too between that and the Christian notions. Judeo-Christian, God created heaven and earth on 6 days, Genesis. Nothing else happened on those days. God just did those things. That was it. And the seventh day he rested. Very literal, but again, another creation myth. Created lights, the oceans, land, plant, and the whole sequence of events. Science has got the Big Bang Theory. Okay, and we'll talk a little bit about that as we get on today. Or, if we look at some indigenous cultures and we look at Navajo right through to our own indigenous people, the giant serpent. Who is responsible? What is responsible for the creation of the earth? And you can have a lot of fun with this with kids. And the Incas, we go back to the pseudo-evolutionary concepts of their mythology and their cosmology, which begins with their concept as a little bit like the Navajo. The earth was a very dark place. It was completely dark. And then the god Kontiki emerged out of a lake, bringing the first humans with him. He first made the sun, the moon, and the stars. Then he made humans out of large rocks. But, as human nature, he's the cross between the Christian ethos. We weren't grateful enough, so Kontiki punished them with drought, and another god drove Kontiki out and turned his followers into monkeys, and these were our ancestors. So you can sort of see the pseudo-evolutionary principles here from the Incas. Now, the Incas were a very civilized race. You could have a lot of fun. You could do a lot of exploration with kids in these social, scientific phenomena. And this is the sort of thing we're talking about for assessment tasks too. What are the possibilities for an inquiry approach here? Where are we going with this? And can we set up some digital cards that may help our students explore this? Moving on, we talked to David Christian this week. Has anybody actually seen the David Christian video? Watched them or gone to YouTube and watched the whole thing? No comments? Yes, watch them. Thank you, Lisa. I really like David Christensen. He tells the 18-minute history of the universe, and it's just captivating. If you were looking for something to build a digital card on for upper primary school kids, here is a wonderful tool, a wonderful resource. And he breaks, the history of the world down into 4 stages. Or thresholds, as he calls them, and he examines them. What is the threshold? If we go back to the etymology of a threshold is an edge or a siphon, and once you go beyond the siphon, of course, about threshing the wheat, you thresh it down to the level where it's husks, and you thresh it then down to the level where it's mush. So it's a constant edge of change. And he goes through each of the thresholds. He describes them beautifully and does it with great theatre. It's a little bit like the Elizabethan theatre. He starts off, the auditorium is entirely dark, and he says, "Welcome to the Big Bang." So you really get an idea of what evolution might have been like. And this opens us to exploring this imaginative side with our students. We can get into movie making. We can get into a whole range of different activities with these kids about the beginnings of the earth, you know, role plays, drama, all of these different strategies. He moves on to look at the emergence of life and does his own live timeline. So if you are struggling a little bit, you're worried about, you know, where you'll go in the future to get some knowledge to teach these subjects, relax. Resources like this one are just absolutely huge. And he goes on to talk about diversity in the environment and, of course, the evolution of mankind and Western profit motive and therefore industrialization and the impact on the environment. So he talks about a lot of these things, and he's, you know, represents, I think, is a really, really good story, a narrative account of the evolution of the Earth. And if you need somewhere to start in this unit, Loxley's good, but I really like David Christian. He does it in a way I think that you as a teacher will be able to translate and use for your students. Now, in the Moodle this week, we stepped through a huge range of earth science resources, just pointing you here, pointing you there. The task for this week was to begin your curation. And that curating resources is literally just editing them, like going through, you do an audit of the resources, you identify the ones that you're going to use, you may break them down into categories, and we know we've got the substrands, you may have, you know, chemical, physical, earth and space, biological, you may break your resources down into each of those, and then you may break them down into, you know, more unit or more elaborations, and you can actually start structuring your resources in a very sequenced way. And the whole purpose in doing that, it's like having a little filing cabinet. You know, when you are teaching science going forward, you can simply go to your filing cabinet of curated resources and you can put together your digital card, because guess what? You will have done it before. Okay, it becomes a very easy thing to do. So what are we looking at? And one we may look at, which I think is topical, came out of the newspaper today and on the radio, and it's on the television all over the place, evidence for the Big Bang. Okay, so what is the Big Bang Theory? Now, on the videos in the Moodle this week, you know, we had Chugs, we had God, we had Homer Simpson, we had a whole range of people talking about the Big Bang, but it does have a science, okay? And there is a huge lot of information about what the Big Bang is. And you know, so an introductory task may be, for instance, a word search. Okay, where you can actually give the kids a little quiz, a word search, where they can go out and they can find the meanings or the key concepts or the key words involved in you know, the upcoming study. Yeah, so we're doing the very, very bottom level of Bloom's taxonomy here, the knowledge and the comprehension. So, you know, they're going out to look at these words and then identify what those words might mean. Once they've done that, we get to understand the evidence that exists for the Big Bang Theory. We move on to the next levels. We're starting to look at the application levels of Bloom's taxonomy. You know, and when we look at a class, we realise that not everybody in our class is going to be able to achieve. And here's one thing we need to look at when we're looking at our digital cards. What is the one thing we want all students to be able to achieve? What is the thing that we want most students to be able to achieve? And in a perfect world, what are the things that we would want our higher order students to achieve? So you design a card, and you know, here's a critique of some of the cards people do in this unit of study. They design it because they think there's a right answer in mind. And the purpose of the teacher in a digital card is to push a student to an existing or a pre-existing answer. The purpose of a really good digital card is independent inquiry. Okay, so in that digital card, you should be sequencing the main pieces of knowledge that you want students to gather. And in this case, it may be the two main pieces of evidence for the Big Bang Theory. So you want students to come out of this digital card, this independent inquiry process, knowing at least two main pieces. You want most students to be able to explain how CMBR and redshift provide evidence for the Big Bang Theory. So what are these concepts? So we've got to do some work at the Bloom's, you know, comprehension level, and how do they work together? You know, we've got to look at the application components. And some of your students will get that, and some of them will get very excited by that, and they will go on to then evaluate the Big Bang Theory of the universe, and they're the ones who will come in tomorrow. They're the ones who will knock on the door and say, guess what, sir, guess what? This has happened. Scientists have discovered this. So all of a sudden we're starting to see them go through this inquiry process where they've taken the main basis, they've applied and understood the theory, and they're now looking out and applying it and elaborating it into the world. So the key words in this little unit, for instance, would be CMBR, redshift, Nobel Prize and steady state. Now, why have I thrown those together? Well, I've thrown them together because one of the resources I might use for a digital card like this would be the story behind the science, a great website. I think I introduced it back in week 3 or 4. And on this, you can actually, on this website, they give you little printed out PDF stories about great events in science, everything from how old is the Earth, right through to, you know, the discovery of the Big Bang Theory. And this is quite a unique story because it involves pigeons. It involves a whole lot of pigeon shit. It involves 2 university students and an existing scientist. It's got jealousy, it's got passion, it's got crime, it's got everything wielded through it. It's a fabulous little story. And these guys actually created, you know, an understanding quite accidentally because they had to clean their little satellite disk away from the pigeon crap because they thought that was a problem. But what they were actually doing was they were receiving information about CMBR. Now, if you don't know what those terms are, maybe you want to go away and find out about it. You know, as I said, the purpose is not to do a science lesson here, but to actually say, here is something that's happening in the papers at the moment. Here is a great way to set up a digital card so that you can send your students out to actually have a look at this as a unit. And here's an example, just a little snippet from the actual article itself. It's about a 4 or 5 page PDF file online. It's definitely upper primary, lower secondary. And it talks again about the origins of the theory behind the Big Bang, and to whom the Nobel Prize was awarded, why it was awarded, and it talks about the 2 university students involved in their accidental discoveries as a result of cleaning up pigeon nests. And there's a whole range of things we can do with a little story like this. So when we look at the evidence for the Big Bang, oops, something's gone on there. We can look at what we're talking about with cosmic microwave background radiation, and this is what we call CMBR. Now, during the Big Bang, the theory is, or the science is, that huge amounts of radiation would have been created and thrown out across the universe, and that's what we see. However, when we look out into space, it's pretty quiet and it's devoid of so much energy. So where has the energy gone? So that was what drove the search for the origins of the universe. Where did the leftover energy go? And this is what scientists were pursuing in the 50s and 60s. And there was 2 university students who eventually found the resolution. And, again, if you know the story, you can smile to yourself. It's a great little story, and students, kids would really, really get into it. So you could set this up as an inquiry task. You may begin with a jigsaw task, and you may give them 5 questions. And these questions may guide their explorations into this particular task. So you may get them to read the information on CMBR. You may then get them to answer some key questions in their notebooks. Okay, that's one way of doing it. It's a very traditional way of doing it. What does the science think? But we wouldn't stop at that level. And this is the problem with a lot of science. It stops with a realization that CMBR is the leftover radiation from the start of the universe. Okay, that's what it is. And it can only be explained by the Big Bang Theory, and its theory is made more widely, and as a result, Big Bang is made more widely accepted. So there's a lot of science in there. You can have a lot of fun with this. But, one way you can do it is to use a jigsaw task. Okay, give each of the students roles. You've got your analyst, your noise monitor for the group. You've got your reporter. Your reporter will come back to the group and to the main group. You've got your timekeeper and your scribe. So you're capturing a record of what happens in the actual group discussion. And here is your investigation. Get them working, get them building some knowledge. And this can be done in a digital context. You don't need to be in a room, okay, where this can be done. You can actually create roles and strategies for doing all of this in a range of online settings. And we'll talk about some of those as we go through. CMBR, as we said, it's the leftover radiation from the start of the universe. It can only be explained by the Big Bang Theory, and its discovery has made that theory much more accepted. So what do we do once we've got answers to our questions? We go to a little task called a spotlight. Now, you may have known this. Well, what we do is we get the reporter from our jigsaw group, and each reporter's got to stand up and report back on one particular question. Okay, and again, here's how the class comes together in its discussion, and this could happen the next day. The task, the actual knowledge component of the task, could be done overnight in a digital card, and the spotlight activity would be the way you would start your class, your next science class, the next day. Okay, so the reporters come in, and instead of the teacher standing up, the reporters come in, and the whole inquiry process starts from where the students sit. What does the Big Bang Theory state? What is redshift? These are questions that have been given out, to the reporters, and this is what the group have gone away to solve. And in the end, each reporter comes back with an answer to the question worked on by the group and reports to the class. What we're doing is moving our whole collective and collaborative understanding along. So some of the questions, just in case you didn't know what they were: what does the Big Bang Theory state? Okay, that the universe was once compressed into infinitely small point and exploded outwards. Okay, and this happened in microseconds. The first microsecond was obviously the heat. From the heat came the gases. From the gases formed the substances. From the substances formed, I guess, the scree or the energy. From the energy, of course, formed the motion, and from the motion, of course, formed ultimately life and structure. What is redshift? Redshift is an interesting principle. And when the wavelength, again, this takes some complex illustrations, but can actually be done quite successfully with small lasers. And there are some online versions of this too you can use. When the wavelength of light increases because the source light is moving away from the observer. Okay, so that's an interesting phenomenon. So that's going to take some explanation. But redshift provides us with the evidence of the Big Bang Theory because, as this article explains quite well, the lights from stars and galaxies is actually redshifted. We can now capture it in certain cameras. Therefore, they must have at one point been much closer to us because it indicates by redshift that they're now moving away. So CMBR stands for Cosmic Microwave Background Radiation. It is the residue from the Big Bang. The people credited with discovering it were 2 university students, Penzias and Wilson, and CMBR is the leftover energy from the Big Bang, okay, which it's if you like, its footprint. So it's a complex scientific notion. So some of the things we can include here: role play activities. We've got to give the students an entry point. Now, we don't necessarily need them to master the entire science behind it, but there's things about it that they can still feel involved with. And, and as using scientific skills, using human endeavour, using social science. We know how CBR was discovered, and we can pick up one of the scenarios that, listed here, for instance, and give the students a role play where they actually look at what CMBR is and how it was discovered. So you could get them to do a role play of or a digital video of the Penzias and Wilson acceptance speech, a court case, for the killing of the pigeons. And they're chasing them away from their little telescope, the radar dish. And the counselling session for Robert Dick for missing out on the Nobel Prize and the discovery of CMBR. As I said, there is passion, there is violence, and there is energy in here. So students, again, there's a whole range of ways to access science. It doesn't necessarily have to be through science itself. It can be through the imagination. You can build a modelling. The penultimate task here could be them to model the universe, build a 3D model. And again, here they can go through various stages. Okay, a whole range of tasks we can design into a little unit here on the origins of the Big Bang Theory. And we can also get into some of the scientific skills here, when we start to bring in some of the substrands. How do scientists use models to explain and predict phenomena? And we can bring in concepts like error and misrepresentation. We give them a group task. Okay, this can be their actual investigation where they design and they implement a model. We give them a 30-minute time frame. We break it down into galaxies and smaller systems. We can give them, we can narrow it down so that they can do something in 30 minutes, or we can make it larger for them to do in an hour. Sharing, they can design a poster or a POE statement to enable students to capture their sharing. Okay, and again, some things that we can put on that, the features of the universe your model represents. What things does your model misrepresent? So we get them to self-study, self-correct. And that's the best thing we can do as teachers, become redundant when our learners start to self-correct. What things about the universe does the model omit or not represent at all? What questions came up as you worked on your model? And these don't have to be complex models. I mean, I've run 2 workshops today here at Townsville for Year 12 students. And one of the workshops involved 25 sticks of spaghetti, a marshmallow, a metre of string, and a metre of tape. They're pretty simple tools. And for 20 minutes, these Year 12 students engage themselves in the complex task of building a tall structure. The Marshmallow Challenge, some of it you may know, a really clever STEM exercise. And believe it or not, only one of the groups actually built a tower that was higher than the average tower built by kindergarten children. So it is a national project. There's a lot of data on it. So if you are interested in the Marshmallow Challenge, just Google it. It's a fabulous little STEM activity for your classroom too, but it involves model making. You know, these resources are out there, and the whole reason I'm presenting this today is look, it's very easy to convert them into a digital card. You've got a learning sequence. All you need to do is work out what your 3 lessons are going to achieve, and if the ultimate is to get them to a model, then where will you use your digital card? How can it add most value to that curriculum intent? How can it most support your pedagogy? Is it at the early stage by getting them to do some knowledge and comprehension? Or is it at the later stage where you give them a jigsaw task and you put it, for instance, in a wiki, and you create a group moderator, and that group moderator is the reporter, and the reporter has to investigate one question. So you've got 6 groups investigating 6 questions. The following day they come into class and each of the reporters gets up using the wiki, referring to the wiki in their own notes, and the group does a small presentation outlining their findings. This is how we're using digital technology. We're bringing affordances to the classroom, and then perhaps we throw them towards modelling a universe, our universe, maybe perhaps just our solar system, keep it simple. Just some ideas there on a learning sequence. Plotting interstellar distances, how do you do it? I always use toilet paper. I mean, when you're working with small children, it's different when you're working with university students or secondary students. But when you're using small children, the kinesthetic, the visual, is very, very powerful. And some of our greatest allies are some of our most simplest techniques. String, toilet paper, cheap alternatives. First thing we do is we do the plotting. Then we do the conversion. We create the scale. Once we've created the scale, we can then purchase a big 24 pack of toilet paper. Once we've done that, off we go. It's out to the oval. And we start to look at the distance between our planets. Now we're starting to do things that kids can start to get their imaginations around. We can do these things. It is possible to make these, difficult tasks quite simple. Thoughts as I'm coming up to a lecture, and I often change my notes. And unfortunately, I've opened the wrong PowerPoint and recorded it. So, own fault, my problems. So it can go wrong in a flipped classroom, and you have to it's all about risk management. And that's the nice thing about doing it in this scenario. And a couple of you are starting to put some things up on the forum, which is great, because other students are starting to feed back. And it's really, really important that you do that you try and nut out and tease out as many potential pitfalls as there are in a flipped classroom and teaching with digital cards. Get them out of the way now so that you've got a really good fine-tuned and finely honed practice. Now, there's a whole range of different software available. This is an old one called Merapolis. And what it is basically it's just a chat software, but it's been converted into what we call a collaborative writing tool. So it enables us to in a classroom, we can actually do a joint creative writing exercise. So if you wanted to do something, for instance, on Big Bang, you could get students to co-write it. And it's done a little bit in a way where students take time or take turns. And it's iterative. In other words, one student will start the creating writing process and another student will add to it. And the aim, of course, is to explore the content and knowledge of your science unit. So this was one, they were looking at space science in year 11, and the teacher decided to take a creative path to looking at it. And so Rebecca and Gary were the 2 team students who paired up on this particular task, and they were sharing a collaborative blog. And the aim of the task was that they actually stretch out each other's knowledge and they illustrate and demonstrate as much knowledge as they possibly can in a creative writing piece about the theme of space they were looking at. So read along with me, because I think you'll quite enjoy this one. And the principle is it can go wrong, okay? So at first, Laurie couldn't decide which kind of tea she wanted. Okay, this is Rebecca beginning. The chamomile, which used to be her favourite for lazy evenings at home, now reminded her too much of Carl, who once said in happier times that he liked chamomile. But she felt she must now at all costs keep her mind off Carl. His possessiveness was suffocating, and if she thought about him too much, her asthma started acting up again. So chamomile was out of the question. All right, we're waiting for the space content. Gary picks it up. Meanwhile, Advanced Sergeant Carl Harris, leader of the attack squadron now in orbit over Skylon 4, had more important things to think about than the neuroses of an airheaded asthmatic bimbo named Laurie, with whom he'd spent one sweaty night over a year ago. AS Harris to Geostation 17, he said into his transgalactic communicator. Polar orbit established. No sign of resistance so far. But before he could sign off, a bluish particle beam flashed out of nowhere and blasted a hole through his ship's cargo bay. From the jolt, the direct hit sent him flying out of his seat and across the cockpit. Okay, a little more space. Lots of creativity, lots of imagination. Okay, Rebecca replies. He bumped his head and died almost immediately, but not before he felt one last pang of regret for physically brutalising the one woman who had ever had feelings for him. Soon afterwards, Earth stopped its pointless hostilities towards the peaceful farmers of Skylon 4. Parliament passes law permanently abolishing war and space travel, Laurie read in a newspaper one morning. The news simultaneously excited her and bored her. She stared out the window, dreaming of her youth, when the days had passed unhurriedly and carefree, with no newspapers to read, no television to distract her from her sense of innocent wonder at all the beautiful things around her. Why must one lose one's innocence to become a woman, she pondered wistfully. All right, this is space science. Where is this going? Gary isn't finished yet. Little did she know that she had less than 10 seconds to live. Thousands of miles above the city, the Andurian mothership launched the first of its lithium fusion missiles. The dim-witted, wimpy peaceniks who pushed the unilateral aerospace disarmament treaty through Parliament had left Earth a defenceless target for a hostile alien empire who were determined to destroy the human race. Within 2 hours after the passage of the treaty, the Andurian ships were on course for Earth, carrying enough firepower to pulverise the entire planet. With no one to stop them, they swiftly initiated their diabolical plan. The lithium fusion missile entered the atmosphere unimpeded. The Prime Minister and his top-secret Collins submarine headquarters on the ocean floor off the coast of Cairns felt the inconceivably massive explosion, which vaporised poor, stupid Laurie and 5 million other Australians. Mr. Abbott slammed his fist on the conference table. We can't allow this. I'm going to veto that treaty. Okay, it's going well. It's going well. Let's blow them out of the sky, says Tony Abbott. Rebecca erupts. This is getting out of hand. This is absurd. I refuse to continue this mockery of literature. My writing partner is violent, chauvinistic, semi-literate adolescent. Gary replied, well, yeah, you're a self-centered, tedious neurotic whose attempts at writing are the literary equivalent of Valium. Oh, shall I have chamomile tea? Oh, shall I have some other sort of fucking tea? Oh, no, I'm such an airhead bimbo who reads too many Daniel Steele novels. Rebecca, arsehole. Gary, bitch. Rebecca, dick. Gary, slut. F you, you Neanderthal. Go drink some tea, whore. The teacher chimes in, finally. A+, I really like this one. The only group to get an A. They really seem to engage with the task. I'll let you think about that. Very colourful. Obviously at a year 11 level, not something we're going to do, but I think it illustrates the principle that these tasks, these digital tasks, unless you give really explicit frameworks and controls, can get out of hand pretty quickly, okay? And they can finish up anywhere, including the pulverization and the death of half the human race. So let's talk a little bit about assessment task number 2, okay? And can I pause at this stage and open the floor for any particular questions? I really want to work with some of the things that are bothering you at this stage.
Yeah, hi, it's Nicole Collin. I have a question. My question at the moment, so where I stand is I've finished my essays and I've got 2 drafts of my cards and my elaborations done. Is with the sequence where I should be kind of documenting that in order for my card to make sense.
Right, Nicole, the sequence really ought to be in your elaboration. Okay, so all it is a table. So basically, yeah. So you don't spend too much time talking in part A. You're going to talk about here we're talking here professional literature. Write a brief comparison of two alternate pedagogies. Now, you briefly mentioned that you can refer to my teacher elaboration for the sequence, to address the teaching and learning sequence here. But essentially, the only time you need to refer to the sequence really is in your teacher elaboration. Okay, you don't need to spend a lot of time.
Excellent, perfect.
Yeah.
Cool.
Yep.
No, well, I haven't yet, and that's what I was just concerned about, that I hadn't put it in somewhere that I was supposed to put it in.
No, and that elaboration just provides the context. That's all it does. You don't need to go into a lot of detail. But for instance, as in the unit we've just demonstrated, the focus may be, for instance, the Big Bang. You may be looking at the origins of the universe, evidence to support the Big Bang theory, and your first lesson, for instance, may be a digital card which sends the students home, or it may be your second lesson where you send the students home and you get them engaged in a virtual jigsaw task. It may be your third lesson where you get them to go home and do some creative writing in a shared blog, okay, as per Laurie and Gary. So anything that you choose to do is that's the focus of part A. You explain why you're doing that and how you're doing that, and its pedagogical value. But it really should only ever appear, the learning sequence should only ever appear in your teacher elaboration. Yeah, I know that's hard to get your head around. Any other questions? Can feedback be used as a pedagogy for science teaching? No, it's not actually a pedagogy in its own right. Now, if you look at feedback, you may shift it into the status of a pedagogical approach by turning it into peer feedback, okay, and peer assessment. But really, feedback is not a pedagogy in its own right. Okay, so just be careful about mistaking pedagogies for outcomes. It's really important when you're teaching. That from our last assessment item, that the feedback process is really what we call formative assessment, that you're working constantly and constructively with the students' concepts and thinking. So it of itself is not a pedagogy. Constructivism is a theory, and within that theory there are different pedagogical tools or approaches to doing constructivism. And the aim of constructivism obviously is to avoid and utilise dynamic feedback to the purpose of helping develop a student's learning schema. So be careful about confusing some of the, and we've had a few of those questions come up. They've been really good ones. Someone talked about digital literacy as a pedagogy. It's not actually a pedagogy, it's an outcome. Okay, so the pedagogy is the how. All right, so that you may build something into how you give feedback, okay, and convert that into a pedagogical approach, but essentially feedback of itself is not. Any other questions?
Colin, it's Jackie. So would you consider learning through play a pedagogy?
I definitely would, yes. Yeah, one of the strongest and one of the best to use, particularly for early childhood learners.
Thanks, Colin.
No problems. Any other questions? I've actually recommended some students look at play-based learning as a pedagogical approach for the early years, and a lot of people have come back with some great ideas.
I have a question, Colin.
Fire away, Laura.
I'm using Earth Space Sciences for my early childhood, and I'm taking the approach that my parents have got no financial constraints in terms of purchasing apps or purchasing resources where they would create things at home. So I guess that's my pedagogical approach, that the children are going to be engaging with their parents in the learning. So I hope that's acceptable.
Look, it absolutely, it's all about context. And as we said, your teacher elaboration will set up the context, and you'll explore the pedagogies in your professional literature and your justification. And providing those two things are consistent, Loretta, you're in total charge of this assessment piece. This is something that you might envisage yourself doing in a classroom in a perfect world. And of course, as reality bites in, we tend to modify our expectations of the perfect world and reduce them back to reality. But it's, there's no harm in dreaming. There's no harm in putting a task out there in a perfect world that you would like to see students with resources and capability and support to use the tasks.
Thank you, Colin.
No problems. Any other questions? I mean, on that note, what this assessment task is really looking at the connections you make. It's sort of saying to you, okay, this is hypothetical, but can you take a digital card? Can you identify 2 different age groups? Each of those age groups is going to resonate with a different teaching approach and resonate more and articulate better to a different teaching approach. So they're going to respond pedagogically to a different approach. What approach would you recommend for this group? What approach would you recommend for that group? Okay, in a short learning sequence, how would you incorporate a digital card into that? Okay, and so you get to, right, okay, here are my 2 approaches in part A, and you'd explain them and justify them. Then you do your digital card presentation, what it looked like to the learner, and then you do your teacher's elaboration, which gave the teacher the context of the digital card and gave the observer the context of the digital card. The aim here is hopefully that you'll swap some of these, that you'll actually pass them around. So when you leave this unit, and we'll make an opportunity for that in the last week, we actually post things to a discussion board and we allow people to access them and share them. So that when you leave the unit, you can walk out with 5 or 6 science sequences instead of just the one that you would do. And sure, you may develop them and change them over time, but what a great way to start your science teaching. With resources that you've seen developed, that you know why they've been done, how they've been done, and what they're trying to achieve. So think about that as a resolution, and just encourage more sharing. It is happening. Unfortunately, our semesters seem a little bit too short. By the time people really get to the stage where they want to share, they're almost coming to an end, which is a shame, because the emergent learning is really just starting to come to the fore at that stage. And that's when powerful learning changes thinking. So let's move on and have a look at what's happened in the forums. Can I urge you, please, there is the Moodle, have your say. If you can, please have your say. If there's things we've done well, it's feedback time. Obviously, as unit coordinator, I have to do a report each year. It's nice to have student perspectives to put in there. What worked well? Okay. You're all budding teachers. You're at that stage where you are virtually one foot in the classroom. So your comments are valuable. They should be insightful. What's working well? What could be improved? And we've seen some excellent work, and we try to give as detailed feedback as we possibly can. So we welcome feedback from you, and even if you don't have a lot of time, please send us something. Let us know that you really wanted to make a contribution back, and let us know how it's all gone. On the forum board, Helen wanted to know about the word count for Part A of Assessment Task 2. And if you haven't looked at the response to that, a quick synopsis there is there's no real word count. It's more the amount of words you need to respond to Part A. And I did put that at somewhere between 1,500 and 2,000 words. And in previous posts, I've given an outline and justification of why I thought that was the case. And also in the Zoom session 1 or 2 weeks ago, I went through and sort of said, well, you really need to using literature. So you've really got to identify what your task is here and who your learners are, what pedagogy exists in the unit of study you're doing at the moment. Identify pedagogy that you're going to use and apply, and justify why. What are the learning benefits from it? And you've got to do that twice. So by the time you've done that, you're getting up to 1,500 words comfortably. And just have a look at the structure there. There is no upper limit, but you've got to strike a balance between just fluffing out answers for the sake of it and punching out information that's relevant to your presentation. So obviously answer the question, obviously give your rationale and justifications, but try not to go too far in that. Try not to go beyond what's necessary. Just address what you think are the core criteria. And in there is the skill in this task, is identifying what it is you think you need to say. And then having the words and the resources to speak that. And then having the aptitude to design a card for learners, and having the teacher insight to tell teachers how to use this card in your elaboration. Okay, so that's what we're looking for. Paula wanted to know about platforms for the digital card, which is a really good question. I'll pick that up in a minute. But she wanted to know about the one that I showed last week, and that was just a screen capture from a Weebly website. So there was nothing fantastic about that, and basically all it was done was printed in colour, laminated, and given to students with a clear highlighted Weebly link that they could type into their computer and location bar. So that was the printed component, and I think it worked. Certainly I was able to use it. So if I can use it, I think any 5-year-old can. So it's a really good one to use. She also asked how the digital card had to be connected to the classroom, and I think Nicole asked that same question today. It's through the teacher's elaboration, okay? And that's how you sort of say, well, here's my digital card, here's the pedagogy underpinning it, here's what drives it. And here in my teacher elaboration is the sequence. Here's what I'll do before, here's where the card comes in, here's the activities, and here's what will come after. Okay, and that's really all you need to do. Okay, and of course it's got to make sense. And Kate has popped up with some more questions on pedagogy. Kate's always got some good questions on pedagogy. Have a look at her posts. Noelle did a fabulous digital card sampler last week and posted it for us all to share. And I sort of watched and a bit disappointed that the feedback didn't come back to her about the power of that card. So I jumped in. I've always got something to say and gave feedback there. Have a look at that. There may be something in the feedback for you. When you're doing your card that you can sort of say, okay, yeah, that's exactly what I'm thinking too. Thanks to Noelle for that. It takes a lot of courage, I think, to put yourself out there. And we've got to remember we're teachers. We're putting ourselves out there every day. And so the sooner we get comfortable with that, the better we'll get at putting ourselves out there. And in the forum too, I've asked you to check that it is in fact a digital card you have produced and not just a teacher elaboration. I mean, if you're going to hand a teacher elaboration to a 4-year-old kid, good luck with getting anything done. Okay, clearly that's not going to achieve its purpose. And so let's have a look at some of these questions in a bit of detail. I'll start with a link to Paula's question above. Is it a digital card you've submitted? This is sort of my own post. And you can see here, here's what a digital card looks like. It's colourful, it's engaging, it's got little cartoon characters on it, it's age relevant, it's grade 1, it links directly to a Weebly site. You can't see that so much there, but there it is. And that was one of the criticisms I had of this card when it was done. That should have been more obvious and more visible. And as you can see, it's a little bit text heavy. It was another criticism I gave it because it is a year 1 card. But by and large, I think it works beautifully. And that production is just a screenshot. That's all it is from a Weebly site. Cut and pasted onto a Word document, embedded in that document and printed. Over here we've got the teacher elaboration. Now that's a fairly short elaboration, but it does explain what's going on here. Probably could have been more detail. I do remember marking this one from last year, and it actually had a lot of detail about how the elaborations worked in Part A. And one of my feedbacks to the student was, you could have just put that in your teacher elaboration digital task card, and it would have been relevant and it would have been embedded and explicit there in the teacher's role. So that was just a presentation issue. The point was all the information was there. But your digital card, I mean, don't just submit this one, okay? Don't just submit the teacher elaboration, because the digital card represents applied pedagogy. Okay, here we can see it applied. There's learner relevance here. There's learner consideration. There's learner appropriate resources. There's a presentation format that goes with it. There's a sequencing. Okay, whoops, and over here and then here, which again was a little point that was made. But there is a pedagogy here that's applied in that card, and you can't see that level of effort in this. You can't see it in the teacher's elaboration. Here's what it looks like to the learner. When you read the two of them together, that plus that, we can see that we have quite a sophisticated response. Plus, we also want to see your full TPAC, okay? Your technological, your pedagogical, and your content knowledge all woven together. So here's a very strong statement of your curriculum and pedagogical knowledge. Okay, here is very much an approach and a statement on your technological knowledge. Read together, we've got your full TPAC there. Also, one of these cards is clearly functional, okay, and we know which one that is. There it is. It's clearly functional. It's for teachers. It's for educators. Here's the sequence. One is clearly for learners. It's about doing. It's a call to action. In this assignment, both should be submitted because they should talk to each other. So please, if you're falling into the trap of just submitting, the elaboration and assuming, well, use your imagination, Colin, that's a digital card in drag, think again. That's not going to happen because you've got other students doing this, okay, and working through the learner and to the teacher. And the dialogue is obvious, it's powerful, and it needs to be acknowledged that the student's making those connections. Anyone like to ask anything more about this before I move on? Okay, good. If you do, just throw it into the forum. No questions, a silly question. Paula talked about getting that digital feeling. Now, you can keep it very simple, okay, to do a digital card. You can do it, as we said, just a simple screenshot. There it is, okay, and that was taken basically just from a web page. You can do it, for instance, just as an image, okay. A couple of suggestions there. Embed it in a document, embed it in PowerPoint, embed it whatever you want. PowerPoint will give you quite a few artistic components to work with if you do embed it in a PowerPoint. You can do it as a Word document. And just some easy ways to do it. Insert a background image in a Word document. Insert text boxes. You can use ones with interesting corners if you want over the image and type relevant content. Organise your teaching sequence. Use screenshots. And for those of you, take a screenshot of YouTube of a clip you want to use, paste it into a Word document, then save the Word document as a PDF, open your PDF, and using your take a snapshot tool in the edit menu, just use the square to select the area you want to copy and paste it into your digital card. Then you can add text around it. You can come up with your own number sequence and designs, a whole range of things you can do. PowerPoint is also a viable option. Okay, you can select an appropriate background of your choice. PowerPoint actually does, themed, as you're well aware, themed backgrounds and letter sets. And it's also got a quick style menu, and under the quick style menu, you can design really cute little buttons. These are for really simple resolutions to coming up with nice visual, learner relevant digital cards that don't require you to do a whole lot more. Yes, you could use Publisher if you had Publisher. Yes, there's a whole range of desktop software that you could use. Not everyone has it. Some of the basic ones will do a very, very simple job. But, it's really the same steps, just in different formats. Okay, just creating an image, embedding it in a document, creating a Word document, then which becomes a dynamic printed card. And then, of course, you can do it as a PowerPoint too. And PowerPoint does give you a lot of options. You can post PowerPoint, for instance, or email it to students as a live document. Same with a Word document, and you can email it to them, give them a printed version, and then send home a task via email. Or if you're using Wiki or using Weebly, again, you can do those embedded resources. Are there any other questions? Anyone else doing something slightly different? Something more complex, something sexy, or something simpler even?
Colin, I have a question.
Yep.
With the early childhood, it's very broad to say I'm going to design a digital card from birth to 5 years old, because a 5-year-old is quite different from a 3-month-old or a 6-month-old. So within that early childhood, I've been specific with an age group of 4 to 5. Is that okay?
That's fantastic. Yeah, and I mean,
because obviously, if I prepare something for an 18-month-old or 2 years of age, it's very different from a 4 or 5-year-old in terms of their development.
Absolutely, Loretta. It is indeed, and that's the whole aim here. You're talking about a digital card that may be used once or twice. They may have it. It may have 2 components to it. It may just have the one. So it's going to live a short time in their lives. So clearly, the more you can focus when that time is and the relevance of the science you're dealing, the more effective the card is going to be. And the failed example we looked at with Gary and the chamomile tea. I mean, the reason was clearly the teacher had failed to define the task well. So a great digital activity, even though the teacher was in denial, went to putt. Okay, the learning was lost. And so, you know, what you're doing, Loretta, the sort of controls you're putting in, the sort of editorial and teacher context you're placing on it are perfect for a task like this. It's going to make the task more successful.
Colin, what I've done is I've created a website, and then all the steps, my 5 E's, are going to be within a page of a Weebly. So for argument's sake, like my early childhood space one, the parents will be given a digital task card with the Weebly site. So that would be their guide, but they'd be able to either use that or go straight to the Weebly and follow the Weebly. Is that okay?
That's absolutely okay. Well, yeah, what we're designing for here is we're designing for learning, okay, but we're creating the space for emergent learning. Now, an educationalist, Eddie Wenger, talked about this in a great deal of depth in the 1990s. All you can ever do is design for learning. That is, work out what it is you want the learners to understand. And beyond that, create the space for emergent learning like you're doing. So your digital card will be the lowest common denominator. Beyond that, the Weebly is going to enable those other students to go further. As we said, work out what you want all your students to get, what you want some of them, what you'll tolerate some of them getting, and then what you'll tolerate the few getting, or what you'll work with the few getting. And once you've defined that, you'll find your digital card will be very effective in reaching your knowledge and comprehension goals. Are there any other questions?
Thank you, Colin.
You're welcome. Yes. Any other questions or comments people would like to make? All right. And in that case, then I suggest we all go and have a nice cup of chamomile tea and relax, and maybe blow the mothership out of the sky, or something else that we might like to do on a Wednesday night. I will try and paste this together and get rid of that old PowerPoint slideshow and put the one in that I actually intended to show. So, but look, thank you for your attention. If there are any other questions, please send them through on the forum. I understand that you're busy. From the level of questions I'm getting, you're really deeply in the task at the moment. So, you know, as things come up, keep sending through those questions. All right. Good night and good luck, and we'll speak soon.